Today we are going to explore a model that addresses the future of energy planning in Egypt, focusing on sustainable electricity supply and alternative energy pathways. Let's discuss some key aspects with the developer of this model. So, could you please introduce yourself before our conversation?
Yeah, my name is Mustafa Shaban. I'm from Egypt. I started my master degree in renewable energy at Kassel University in Germany. And then I started my PhD at Hamburg University in 2014. And this was the topic of the model that I developed.
Thank you. So first, can you explain the purpose of your model?
Yeah, sure. The purpose of the model has been summarized in the title of my PhD thesis, which is the roadmap to energy security in Egypt. Basically, there are three challenges behind developing the model. First, the energy crisis in Egypt, which has started since 2012 due to shortages in natural gas, which is the main energy resource for power plants in Egypt. Second, the importance of looking for sustainable alternatives in the future that would reduce the progress of climate change and consider not only the economic and technical impacts, but also the social and environmental ones of power plant technologies to be in line with sustainable development goals. Third, the complexity of energy systems and the influence of interactions between decisions by different actors, as well as impacts of spatial factors in the decision-making process. For these reasons, we try to develop a model that explores the dynamic transition of energy landscape under different scenarios and conditions, with an emphasis on alternative energy pathways and a sustainable electricity supply mix as part of an energy roadmap until 2100.
Moving on, what were the main challenges in developing the model, especially, integrating ABM, GIS, and MCDA? How did you manage to combine these different systems within one model?
Basically, I faced some challenges in developing the model. First, I had no past experience in system modeling nor programming languages. I spent some time in learning these methodologies, the multi-criteria decision analysis, GIS, spatial analysis, and agent-based modeling, and also learning NetLogo software, the GIS tools such as ArcGIS. And yeah, I tried to bring these methodologies, like writing a code of the model by including these different methodologies. There was a second challenge, which is collecting empirical data about the initial preferences of the sustainable criteria for analysis of electricity supply technologies by four groups of stakeholders. So I had to meet experts in power plants in Egypt, policymakers, investors, and young researchers, and it was a bit difficult to collect data from those actors.
As for the insights, what are the main findings coming out of the model analysis?
Well, it might take half an hour to describe the functionalities of the model. However, briefly, the model investigates seven electricity supply technologies. These are coal, natural gas, concentrated solar power, photovoltaic, wind, biomass, and nuclear. And it considers four dimensions of analysis: economic, technical, social, and environmental, including indicators under each of these dimensions. In addition to seven spatial factors, namely resource potential, population density, availability of roads, water, grids, political stability, and potential negative impacts on agriculture. And as I mentioned, that it includes four actor groups that I mentioned in the last question. And there is another one virtual actor. It's like a sustainable actor, and the game scenario, which includes the interaction of all actors. So the model shows the change in the priorities of each actor tied towards the different technologies in general in whole Egypt and in space with a resolution of 440 square kilometer. It also shows the evolution of greenhouse gas emissions under each scenario. The sustainable scenario, it considers equal importance or preferences to all sustainability criteria, whereas in the game scenario, we include all actors in the analysis with the rule that makes the technology with the maximum priority between all actors and technologies the best alternative. So based on these results, we anticipate the future electricity mix that would be preferred by each actor group and under the sustainable and game scenario until 2100. We found also by compiling the technologies that power plants based on renewable resources would exceed those based on fossil fuel in the future in Egypt. So it's kind of simulation of how the system would develop in the future, and then we can test different conditions and scenarios with the model.
Can you, how do you think about the applications of your findings in the real world?
Yeah, it's a bit challenging because most of the people who use models in electricity sector, they prefer the optimization model. And they also published a paper comparing the using agent-based models in comparison to the optimization model for the electricity planning. And unfortunately, most of the people, they consider the optimization model, or they prefer using optimization model, and they concentrate also on the technical and economic aspects. So the economic or the environmental aspects are not so important. But we try to further to spread the idea of how it's important to consider this agent-based model, because it's like kind of interaction, especially when you have some private sectors and the suppliers are different. They offer different types of electricity technology, and then there might be some kind of competition between these technologies, and the consumer also have to decide which one to choose in their planning.
Next, you've made your model available using comsys.net website. So, what were the main challenges to making your model available to others and archiving that using comsys.net?
Yeah, basically, I shared it with my colleagues who also work with agent-based model in my former research group, or some actors in the electricity sector in Egypt. I added it also to my ResearchGate account. The model also is linked to a paper published in the Journal of Artificial Societies and Social Simulation. The title of the paper is Dynamic Sustainability Analysis of Energy Landscape in Egypt, a spatial agent-based model combined with multi-criteria decision analysis. So probably those who read the paper would have access or can have a look on the model, because it's already mentioned in the paper.
Thank you. So, lastly, what's next with this topic? Are there follow-up studies available or planned to extend this model?
Sure, I developed another model as a follow-up to that one, but it has been applied in another field. It's called the VISA model, which stands for the viability of the social ecological agro-ecosystem. I published two versions of this model. They have been peer-reviewed and published on the ComSys network platform. Actually, VISA simulates the decision behavior of different stakeholders, showing demands for ecosystem services in the agricultural landscape. the actors attempts to improve the provision of ecosystem services such as crop yield, soil erosion control, water availability, biodiversity, and carbon sequestration in an agricultural landscape in a case study in Germany, while keeping or improving their capital. But here we are not concerned only with the financial capital, but we include also social, physical, cultural, human capitals in the investigation. So it's an extension of the ELTAP model that I developed for the energy landscape transition planning. But here we applied it in another field in another project.
Thank you. Thank you for joining me and sharing these insights with us.
Yeah, thank you.